This is the final report of ChomskyLovesDL deep learning about question and answering system. The task is to generate question and answers based on Wikipedia. The system consists of question generation part, which generates questions in two approaches, and select n questions from ranking, and the question answering part, which generates answers for each question. We do pre-processing in scrapping, tokenization, stop word removal, pronoun transformation, and parsing. We first define questions into categories of binary questions, how questions, what, who, when questions, and compound questions with examples. Our first approach is structured question generation. We try to split the corpus into topic description pairs. Then we could form the question by selecting a specific topic and key phrases from description. A typical wiki page follows a hierarchical title-subtitle description structure, where we could construct pairs to generate more specific questions, like say early life, Alex Morgan, club career, Alex Morgan, etc. Also, it could also boost generation by pointing a more specific piece of description of a topic to ask questions. Then we fed the pairs to templates like how is A of B, is A of B adjective, do you think A is B? And the set of adjective is a predefined set with additional adjectives from the description. In this way, it covers both the general adjective and the special adjectives. We also resample and mix the topics for misleading questions. Because sentences use pronouns to refer to entities in the corpus, and we could only be able to ask questions about sentences where the entity, say Tom, is explicitly referenced. Thus, we conduct coreference resolution. If we resolve he to Tom, we could ask question, how old is Tom? Thus, we decipher what is the main entity in the question is and what its attributes are. We implement coreference resolution based on a set of dependency relations and thus identify Tom is cat. By generating the relation map, we can manipulate the order of words in the sentence based on the part of speech to generate questions. When we identify Tom and cat, we can able to ask questions like, is Tom a cat? And for approach 1, in binary question, we extract topic pairs and section subsection to form the question, with adjective extracted from description and form a sentence like, was the public response of NFL season 2009 successful? And for approach 2, we use the parse tree and find an instance where the noun phrases is followed by an auxiliary verb. Then we swap the positions and replace full stop with question mark. For example, we will have is CMU a big university from CMU is a big university. For compound questions, we find the auxiliary verb corresponding to the main verb and positions it at the very front of the sentence. We convert that verb to the root form and add a question mark. Then we have, does Roger work in the park from Roger works in the park. We employ a similar method for how question in approach 1 and got how was the international career of Alex Morgan, where A and B are sampled from hierarchical structure of the corpus. And for what and who questions, for example, we could also get what was the public response of NFL season 2009. We extend approach 2 to pronoun due to the pronoun transformation and dependency parsing. We use NLTK's human name tagger, replacing person name to who and object name to what, and then we could get what is the basis of science from evidence is the basis of science. For why question, we identify subordinate conjunctions such as because, since, so, and due to. The phrases follow these conjunctions will be the reason for why, and then we could form a why question by first generate a binary question and turn into a why question. After primitive description generation, we add a variety of questions generated by doing word transformation using semantic relations via WordNet. Say we got is John a benevolent person from is John a kind person. We also use a question editor to increase the diversity of questions by changing the template in multiple forms. From is A and B the same, we can get what is the relationship between A and B. After generation a large set of questions, we employ a scoring function to score each question based syntax and length criteria. We penalize on syntax errors and overlength. Therefore, we encourage question to keep a good syntax style and reasonable length. We then select n lowest score questions to be the output. For question answering, we do query expansion and then query classification based on what type of question it is. Then we continue with a similarity-based search and finally end with some text processing on a case-by-case basis. We pre-process both the corpus and the question and expand the query by replacing hypernames and hypernames in WordNet to get a larger candidate set of questions from n to k plus multiple with n. We employ a key pronoun matching, especially the first word in the sentence, to determine the category of the questions. Thus, it is much faster than parsing the whole sentence. We might see expanded set of queries by each sentence in the corpus using fuzzy similarity and retrieve the most similar sentence to the given question. After picking the sentence, we employ a question processing for different question categories. For binary question, we detect the number of negations in the sentence to choose whether the answer is yes or no. And for where, when, who question, we change the pronouns by selecting the matching entities in Stanford NER parser and retain the entire sentence if no matching. And for how question, we split the sentence by and use the latter part as the answer. For why question, we split by connected words and use the former or latter part to form the answer. Similarly, we could deal with which, what on categorized questions. And this is the overview of our QA system. Thank you.